Today we're going to solve quadratic equations by factoring. As a warm-up, we're going to quickly review solving quadratic equations by graphing. Factoring is going to give us a second method, but graphing was our first method in order to find the solutions or roots to our system, or to our quadratic equation. So again, we have to find our A, B, and C values. We can tell this parabola is going to open upward. Find the x-coordinate of your vertex, or the axis of symmetry. Once we've done that, we're going to make our t-table. Vertex is at 1/4. In order to have the same y values on opposite sides of our vertex, we have to be the same distance away when we pick new points. So, because our vertex is at 1/4, if I pick a value that is less than 1/4, if I go to 0, that's 1/4 away. 0 to 1/4 is a distance of 1/4. So if I'm adding that on to find a value that's greater than 1/4, I would go to 1/2. Then I can continue to space my points out in increments of one whole integer. Once we find our x values, we're going to plug back in our y values. And then we can graph our points. Very close together at the bottom of our graph. One and a half, we're at -3, and -1, -3, and then -2, and then 2.5. When we look at our graph, we can see that we're not crossing the x-axis at 2 exact points, but we can see we're between 2 points here, and this might be at an exact point at this one right here, but that's why we want to check our t-table. So if we look at our t-table, we do have a solution at 2, 0. And since that's not a point that we picked, we can always check that by plugging it back into our equation. But this does wind up at 2, 0. If I plug in 2, I am going to get 0 for my y-intercept. So that is going to be one of our solutions. The next one, if we look at our t-table, we are changing from a positive to a negative in our y values between 4 and -3. So our solution is going to lie between the x values of -1 and -2. So those are our two solutions. Moving on. So we can solve a quadratic by graphing like we just reviewed, and by factoring. We have reviewed how to factor, but now we're going to find solutions using factoring. Just remember the zero product property. If A times B equals 0, then A equals 0 or B equals 0, or A and B are both equal to 0. So for example, if I pull out a GCF of x, which means it goes in front of my parentheses, I automatically know that x equals 0 is one of my solutions. My other solution would be found by setting what's inside my parentheses equal to 0 and solving for x. Solve each equation by factoring. Do not divide away a variable. You could lose one of your solutions like a solution of 0. So do not divide away anything. Always move everything to the same side of the equal sign so that your quadratic is set equal to 0, and then factor. So when we factor this, we have a GCF. X comes out, we're left with x plus 4 equals 0. Again, the zero product property happens, so x equals 0 is one of our solutions. Set the other quantity equal to 0, so x equals -4. We should check our solutions. If we plug them back in, does 0 work? Yes, it does. Does -4 work? Yes, it does. Moving on. Again, set everything equal to 0. Make sure your x squared term is positive. And this is a hard 3-term factoring. So we look for factors of 3, which are, and factors of -2, or, so they have to multiply by those 2 end terms and add to give us our -5 in the middle. It's a game, again, of guess and check. We know we have to use 3x and 1x. We just have to figure out if it's -1 times 2 or -2 times 1. Check. 1x, -5x, or I'm sorry, -6x, which would add up to equal -5x. So that's what we want. Set both of these equal to 0, and then solve for x. And then x minus 2 equals 0. If we check those, do a quick check mentally, they both work as solutions. Another one we're going to set equal to 0. 3-term factoring. Oops, x minus 3, x minus 3. When we set either of those equal to 0, we get one solution at x equals 3. Quadratic equations of the form x minus p and x minus q equals 0 have roots of p and q. Write a quadratic equation with -2/3 and 6 as its roots. So now I've given you the roots, I want you to go back and write the quadratic equation. Write the equation in the form of ax squared plus bx plus c equals 0, where a, b, and c are integers. So if I've given you these roots, we have to plug them back into our parentheses. So remember, inside our parentheses, there's always a minus. So if it's x minus -2/3 and x minus 6, this turns into plus a positive. How am I going to simplify this? I have to FOIL. Or do your sneaky squares. When we FOIL or sneaky square, we get x squared minus 6x plus 2/3 x minus 4 equals 0. Write in quadratic form. Remember, in order to add these two terms, you have to have a common denominator. So in order to get a common denominator, we have to turn -6 into a fraction of -18/3. So we can combine those. Now, you may not leave a fraction in your quadratic form. That's improper form. So in order to eliminate our fraction, we multiply the entire equation by 3, meaning every term gets multiplied by 3. So our proper form would be 3x squared, x squared minus 16x minus 12 equals 0. And that is our quadratic equation.